Hello guys, this is me and this is day 20. Hello guys, this is me and this is day 2 and 3 of project 2, and I had recorded the video for like 40 minutes and the video got corrupt. So I have to explain everything again and hopefully I can do this quickly. But see, this video is going to be day 2 and 3. uh, I don't know how to say this, but I have to go somewhere tomorrow, so tomorrow is not going to be a day that I will be able to fulfill anything. So oh Shadmo, I genuinely had recorded such nice video for this and it got destroyed. I had explained everything, like everything from I had explained this, I have explained this, I have explained this, and right now genuinely I'm not in the mood for doing it anymore. I will just still try to do. So let's look at the data types here. So in the integer stuff we got short, we got int, and then we got long. So this is the in the integer values, and in the base 10 decimal values we got float, and then we got double. So double has more range than float. It has more size than float. So this is the order of range, and then we have character, and then we have string. So what is string? String is basically like a library of characters. So it indexes a, characters in this ways. So this is a string, and basically a character only has 1 byte of data. It can store a or it can store b. It only stores this. And let's look at another thing. Let's look at binary. So short consists of 1 byte, which means 8 bits. And what is a bit? 1 bit means 0 or 1. Okay, so 1 bit means 0 or 1. And this thing here, short, has 8 bytes, so it holds 1 2 3 4 5 6 7 8, this many kind of data. So how many possible stuff are there? So let's make it in a block and see, each block can have one value. So it can have 0 or 1, 0 or 1. So this is two values. Each one can have two values respectively. So the total is going to be 2 to the power 8, which is going to be 256. So there's a 256 total combinations, and let's represent this in a form of negative and plus. So how can we do that? We'll break this in two. So this is going to be 128 plus 128. So this is going to be minus 128, and this is going to be 127. Why not 8? Because we are also including 0 here. So this here, not including 0, is going to be 128, and including 0 to this is going to be 128. So total number of combinations is still 256. So this is how everything works here. So I have made you understood what that is, and let's see this. Okay, let's first of all, this hashtag means this hashtag is a preprocessor. So before my compiler does any work, like at all, this is telling it to, before doing anything at all, you first include the iostream folder. Iostream is like a folder, like a library of various different stuff that is contained in it. So this hashtag is telling to, before doing anything, like before even looking at this thing, you first include this, like how dealers make you sign illegal contracts. So uh, like that. So first of all, what is iostream? Iostream is like a folder, a library that contains a lot of stuff. So in this lot of stuff, it has another library name which is called standard. So standard is actually a library name that includes our things that we are going to touch, that is going to be COUT. This is character output. So this is our default print statement under IOStream. Don't forget this is all a group, so don't forget that. So count is basically character output in IOStream, so that is good. So what does this does if we are using something like this? So what this does is basically we are saying print hello through character output, and what is going to character output is going to do? Character output is like a function in itself and is going to output it in our screen like that. So this is how IO streams on all this works, and this is why we are using a namespace of standard. And let's comment this. So this is comment open and this is comment close. We commented the whole thing. So the now it's got an error because the code can't find what even is count. So we have included IOStream, so we are going to use standard here. So it is telling inside IOStream there is a library called standard, and in that standard there is something called account. So if we commented this, we actually are using this by default. So if we remove this and we remove this, oh wait, I think this should be there. So see, now it is going to find, okay, we are already inside the namespace standard and count is visible. It's a local variable now, a local function now. So it's now here, so it doesn't matter. And what is the thing with this int? Okay, I understand main is a function, but what is int? So see, int is basically, so int does not care what this function carries. It can like have a, a universe to create God, and it doesn't matter. So it only matters of what is going to be returned from this function. So we are using return 0. So int is this value. So even it doesn't care what main carries or what main is. It's just there to represent what the output, what the returning value of this process is going to be. I can still have no value if I write void, and see now return gets an error because it doesn't what is returned. So if I just remove this, everything is still going to be work fine. Okay, first of all we are going to be using gcc test.cpp uh, o and test.exe. What we are doing is we are telling gcc, okay, you see this, you see this, you use this and you create a executable file from this. This is going to be like a very separate thing, so it doesn't will need gcc in the future. Gcc will already create it as an executable. So we are doing that. Main must return int. Okay, okay, so main must return int. So that like has like a condition or something, I don't know. I'm not trying to challenge it right now. So main must return anything. Okay, because main is the like the only function here. So it must return 0 or 1. So 0 1 is actually like 0 is actually the base thing that is going to be checked. So if it doesn't return 0, the program doesn't know if it actually worked, if it actually ran. So it's just going to give an error. So, but if we have 0, its logic are going to be incompatible. So it's, if we return 0, it is going to think, yep, we did that, so now we can execute it. So it's something like that, like the idea. I don't think it's the way I'm saying it, but the idea is still the same. So let's do this again. Let's update the value. So first of all, when we did this, let's ignore the error. If we did this, this whole thing is going to be created into an executable. So let's say I created right now, and let's say I run this. It's going to be pressing layer and great. So this is like a thing that tells, okay, you need to skip this line. So to skip this line I'm using this. This is \n. This means next line. Okay, so let's say I remove this value. I write it here hello. I write here. And if I going to, if I go, let's save this, and if I going to run this again, it's still going to press there great. Why? Because this hasn't been updated. These two are not these two are completely isolated systems, so this is not the same thing as if I change the CPP, the this thing doesn't change. But if I update it right now and let's say I run this again, it is going to print hello great. So this is how this works, these things work. And zero actually means this folder, so this is the folder I'm talking about. And dot, I mean, I said zero before, but no, this dot means that you are run test.exe from this current folder, this current location. So yep, I guess guys, this is it for day 2 and 3. I'm not going to be available for day 3, so this is there. And let me just show you another thing that I showed in that video that got corrupted, is how binary stuff works. So let's say I have 101. So you do 1 into 2 to the power 2 plus 0 into 2 to the power 1 plus 1 into 2 to the power 0, which is going to be 4, and 1, this is going to be 5. And why is that, you may ask? Like seems pretty random to me, but because see this, we have 0 0 0, this is the lowest value, this is going to be 0, and this thing plus 1 is going to be 1, so the next lowest value is going to be 1. So this value will return 1, and the next lowest value from this sequence is going to be 2, so this thing is going to be 2, and the next will be obviously 3, so this is 3. And see, the next lowest value that this can achieve is 100, so this is going to be 4, and the next lowest value is 101, so we got 5. And if you can notice, you see, the first time the ones place is changing into 1 is 2 to the power 0. The next place, the next time, for the next first time something from this is changing into 1 is going to be 2 to the power 1, and the next thing is going to be 2 to the power 2. So now you can get the idea of why we are multiplying it by 2 to the power 2 plus 1 into 2 to the power 2, and that's all. So this is how binary stuff works. And guys, I guess I have to say it now, but this is it for day 2 and 3, and I will see you guys in day 4, and hopefully this thing doesn't get corrupted. If you're seeing this obviously doesn't get corrupted. So I guess this is it for day 2 and 3, guys, and I will see you guys tomorrow. No, not tomorrow, in day 4. Bye.